Hello. Today we're going to be starting lesson 2.2, which is inductive and deductive reasoning. Now, you're going to hear me referring to these two words a ton throughout geometry. So you really want to get used to them. Now, never am I going to ever ask you to write down a definition, but I might say to you, class, I'm looking for a deductive type answer. Or class, I'm looking for you to think inductively. So it's really, really important that you understand this. Now, I'm not going to read all this to you, but a couple things here is a conjecture is almost kind of like a hypothesis in science. Like we're trying to figure out a pattern. So if you notice down below here, you'll see all these questions about a pattern. So that's kind of what a conjecture is we're trying to figure out something based on some pattern or observation. Okay, inductive. So inductive reasoning is when you use a pattern. So I'm going to almost like double highlight that. So inductive is when you use a pattern. And so again, that's going to come up a ton. And I know it seems really easy right now, but I promise you come chapters 3, 4, 5, I'm going to say use inductive and someone's going to ask, what does that mean again? It means look at the pattern, okay? So if we take a look at number 1, I'll kind of do this one for you, or do this one with you. They want us to predict the 10th spot. So clearly we would have like spot 8, 9, and 10, okay? So if we kind of look at this, we've got this triangle, and I'm going to kind of notice that this is in the right, this is in the left, and then it's on the top. And then notice it goes back to the right, the left, and the top. So I'm kind of noticing like every 3, it's like repeating. So this would be right, and then left, and then top. And then this would be the 3rd cycle. So then the 10th one I can draw would be in the right corner again. So that would be my 10th pattern. Okay, so why don't you see if you can come up with the patterns here for 2, 3, 4, and 5. Go ahead and try all 4 of these. Okay, hopefully you paused it. This one can be a little tricky because the curves, but what I did was I kind of looked at it as the quadrants. So I thought of this as in quadrant 1 is in quadrant 4, 3, 2. Now notice it does go back to quadrant 1, but the pattern, the shape is a little different, but that's okay. Let's just keep this up for a second. So I've got 1, I've got 4, and I've got 3. And again, notice the 3s look a little different. So in spot 8, 9, and 10, this should be in pattern or in quadrant 2 up like this. And then it's going to repeat again. So it's going to go 1, and then it's going to go back to the 4th. And if you notice, every time the 4th was the same. So I can go ahead and draw that. And that would be my answer. Okay, number 3. Again, I had to kind of watch. And so I was like, okay, this one, nothing different, different, still different, still different, right? And then I noticed these two were the same. So I kind of drew my line here and said, okay, this must be pattern 1 again. And then in spot 8 would be the 2nd pattern, 9 would be the 3rd pattern, and then 10 would be the 4th pattern. So I did 2 triangles, a circle, and a square. Sorry, that's not a very good circle, and a square. Okay, so again, I kind of was waiting to see where the pattern repeated. I'm sure you probably like more the numerical and the letter or in the alphabet one just because it's a little bit easier for our brain. But just remember, like this is spot 1, spot 2, 3, 4, 5. So we've got to go 6, 7, 8, 9, 10. We got to get out to the 10th one. And so what I was kind of noticing here is, first of all, it's definitely alternating its signs. So I was going to say this is negative, positive, negative, positive, negative. So I knew that it was alternating. And then, you really had to think about this, but these are prime numbers. 2 is the only even prime. So 2 is prime, 3 is prime, 5, 7. Now, 9 is not prime. 9 is not prime because it's divisible by 3. So 9 is not prime. So then you would go 13. 15 is not prime. So you go 17. 19. then not 21, but 23, not 25, not 27, but 29. So my answer is 29. So this is the set of prime numbers with alternating signs. So alternate your signs, positive to negative. And then this one is the alphabet. And if you notice, it started at C. So if you kind of think about, like, again, spot 1, 2, 3, 4, 5, we would need 6, 7, 8, 9, 10. So if we do C, notice it skipped D, and then E, then it skipped F, and then G, and then H, and then I, and then J, K, L, and then M, and then N, and then O, and then P, Q. Hold on, I'm losing track of where I'm at. 1, 2, 3, 4, 5. So this would be 6, 7, 8. Okay, so Q, R, S would be 9, T, and then U would be 10. Had to really stop and think about my alphabet there. Once I got out of sync, maybe I could have just wrote down all the alphabet and then went through and counted, but notice I had to remember how many I've gone through to get to the 10th one. So inductively is when we use patterns. Again, this is a really, really important detail to remember, okay? So patterns, patterns, patterns. All right, now the next part is they're asking us to make and test a conjecture about the following statements. So it says the product of any three negative integers is what? They want us to make this and test it. So like, what is this going to be? So let's say we take three negative integers. We can pick anything we want. And again, if I was there with you, I would have you guys throw it out. But again, let's not... Well, I got my calculator here. So how about I do three negatives? How about -5, -2, -30? Okay. How about I go -8, -27, -147? Okay, both of these are even, aren't they? Let's see. How about -2, -7? Actually, no. Let's do all odds. -7. We can do -7 again. How about -11? Okay, so we know it's not going to be even because we can get it to be odd. But do you notice how they're all negative? So the product of three negative integers is a negative number. So basically, we just kind of almost in a way finished the conjecture. So let's see if you can do number 7. The sum of any three consecutive integers is what? Now remember, three consecutives would be like 2, 3, 4. Or 12. No, I don't want to use 12 because that's so similar. How about like 16, 17, and 18? Okay, so they have to be in a row. So whatever number you start with, then you do up 1, up 1. So see if you can quick test this. All right, I'm going to quick jot down my answer. And again, I'm not sure if that's helping you, but if you actually take a look at this, if you take this middle number here, 3 times what gets you 9? So 3 times 3. How about what if we take this middle number times 3? Now that's a hard pattern. I'm not going to lie. I do think that's a hard pattern. And again, if I was there, I would say throw out yours. Throw out any consecutive. Like let's say you pick 51, 52, 53. So if you take 51, 52, 53, but again, they have to be consecutive. So if you take those, watch if I take the middle number times 3. It always, always works. So the sum of any three consecutive integers is, I said, the second number times 3. That's kind of how I wrote it. Notice it's not real fancy. I'm not expecting for a paragraph answer here or anything, but they're looking for somehow to give a summary of, like, you know, If somebody threw three random numbers at you, how could you describe what this would come out to be? So write it however you want. Okay, we've already seen counterexamples. I don't know why like it officially shows up in this lesson when it was already in 2-1. Sometimes this book jumps around a little bit, but anyways, it comes up again. So you already kind of have a heads up. But the biggest thing you have to remember is with a counterexample, you have to have one part true. Now, if it's not a biconditional, it has to be the first part, okay? So you want the if to be true and the then to be false. So if it's a biconditional, you just have to have one of the parts be true. But if it's just a regular conjecture, then you want just the first part. So again, sometimes it's just best to see the examples to know how it works. So it says, if the segments are equal, then K is the midpoint. So if this, let's say, is JK, however long it is, let's say it's like 2 centimeters. If KL, so K to L, has to also be 2, does this have to be the midpoint? And I wish we were together because I would say no. Look at this. KL, I can make it still 2, so I can make this be true. But is it in a straight line? Because to be a midpoint, it has to be a straight line. So my answer would be false, and then I would probably just draw you a picture. Because to explain that would be a little bit more difficult, but drawing a picture would suffice. So let's try one more together, and then maybe you can try the last one. If x is a real number, so I can pick any number I want for x. So x can be 2. You can pick x to be negative 1.874. I mean, I don't want to pick that because it's kind of crazy. But if x is a real number, when you square it, will it be greater than x? So if you take 2, will this be greater than, this right here. So if x is a real number, then the value of this is greater than x. So this is really what we're looking at, but we're just picking a number. So if we take 2 squared, will it be greater than 2? And so I look at this and I'm like, yeah, because 4 is greater than 2. So this works. But what if we do this crazy one? Where's my calculator? I definitely don't want to square that in my head. So is this number, is x squared greater than the original number? And when I look at my calculator, this is roughly 3.5, so it's greater than the negative. So far I'm like, yeah, this is looking like it's going to work, isn't it? But what if you pick 1? What's 1 squared? Is 1 squared greater than 1? And the answer is no. So I would say this is false. What if x was 1? What if x was 0? What if x was between 0 and 1, like a half or something like that? Then it wouldn't work. No, I'm not saying that you can pick, there's a few numbers that work. There's, quite a few depending on how crazy you want to go with decimals. But there's a lot of answers that wouldn't work as well, okay? So, why don't you try number 10? Why don't you pause it here and try number 10? Okay, in number 10, we've got a triangle has 3 acute angles. So you've got to come up with acute angles for 3 of them. Do they have to be 60? Now, hopefully you remember that a triangle has to total 180. So you've got to think of 3 angles that total 180. Now, they're saying they don't want you to be 60 because if you do 60 3 times, you get 180. That's called equilateral, equiangular. So, can you come up with another combination? And so, now you got to do acute, so each one has to be less than 90. I was sort of thinking like 50 plus 50, because that gives me 100, and then 80. That's 180, right? And those are all acute. and they're not 60, so that would be my counterexample. I would say false. What about 50, 50, and 80? Those are meet the requirements, okay? So in that one, there's tons of combinations that would work. And again, if we were together in class, I would be asking you guys. So that right there, I would kind of say is part one of the notes. And again, I know I'm going kind of fast, but I want to try to get through this and not make it a super long video. The second part of the notes is deductive. So if you remember at the beginning, I told you inductive, which is your patterns, and now we're going to go into deductive. So deductive is when we use, I'm going to skip over the word facts, is mostly when we use our definitions, our properties, and then you're going to hear this in just a few minutes is what we call our laws. Okay? We have tons of these. Your properties are almost more your algebraic ones. So that's like your associative, commutative. You're going to start to get quite a few definitions, and you know some of them, like definition of acute angle. You already know that it means it's less than 90 degrees. So there's lots of definitions out there too, okay? So if we take a look at an example, it says if angles are vertical, then they are congruent. So if you're vertical, like if you're formed crossing lines and everything, if you're vertical, then they're congruent. So we can say angle 1 is and angle 2 are vertical angles. So we would say, therefore, they're congruent to each other. So all they're really doing, you know what can be kind of confusing here, is all they're doing is they're taking this statement, and then notice this is like the P and the Q, and then this is the P. So then you're concluding Q. So all you're kind of doing in a way is following a pattern, but you're using in a way a law followed or conjunction with a definition of the word. So you're kind of using two in here. What you're seeing in this is called the law of detachment. So the law of detachment is when it follows this pattern. So notice if it's raining outside, then I will bring my umbrella. Now we have no idea if that's really true or not. They're actually trying to get you not to think mathematically here. So if it's raining outside, then I will bring my umbrella. Notice it's raining outside, which is the P. Do you see the pattern? So they're concluding Q. Okay? So law of detachment kind of follows this pattern. Now, if you ever see these three little triangle or three little dots in the shape of a triangle, this is like the answer that you give. This is like the conclusion, okay? So they give you this, and then you say something about Q, okay? And sometimes notice how it's very repetitive. And then notice sometimes how in the beginning statement, it didn't say anything about angles 1 and 2, but now we're going to use those in conjunction. So sometimes it gets a little bit more specific and sometimes it doesn't. So the law of detachment, okay? Let's jump down to a number 11 and we'll see another one here. Notice it says, if it's really cold outside, then you should head out early to start your car, okay? It's really cold outside. Isn't that the P again? So then all we do is conclude, you should head out early to start your car. And that's all we would have to say. Okay? Now this is the next one. This is the law of syllogism. So let's skip that one for a minute. And let's go down here. Look at number 13. It says, if it's sunny outside, then you'll wear your sunglasses. See how I'm just kind of marking up the information. I'm not saying this is true. Maybe I don't like sunglasses. I'm just identifying the parts. It says, you wore your sunglasses. Do you see how that's this part? So this is the Q. This breaks our pattern. So if it doesn't follow the pattern, then we have to say no conclusion. And so that one we would not be able to make an answer or give an answer. Okay. I know I skipped 12. We'll come back to that, but why don't you try 14? All right. Hopefully you tried 14. It says segments have the same length, then they are congruent. I know this doesn't say exactly, but isn't this a segment in a segment? And then same length, that's what this means. When you don't see the bars above it, that means length. So this is your P again, which means you need to conclude congruent. So all you have to do is switch this to the congruent symbol, and then you'd be done. Okay? So let's try the other one, because we're kind of at the end of the page here. But let's try law of syllogism. So notice it said at the top that there was 2 laws that they're going to go over. So we just did law of detachment. Now we're going to do law of syllogism. Now, law of syllogism is significantly longer. That's a lot of times how you can pick out the law of syllogism, because what you'll notice, if I go to the example here, see how it says if, then, and then it says if, then again. So law of syllogism is longer, okay? Notice it says if P, then Q, okay? So I've got P, Q. Notice the second sentence says Q, R. So R is kind of like a new piece. So this is what they give you, and then this is what you would conclude. So then you would say conclusion, and do you notice how the Q's repeat? So you're going to cross these off, and you're going to put P to R. Now, oftentimes at this point, this is where I get the, where are we ever going to use this question? And I totally understand. First of all, I can tell you, one, I didn't write the book. I didn't write the curriculum. But second, they're just trying to get you to follow a pattern. Okay? There's many things in life that we may or may not agree with, but sometimes we have to go with what the law states. And if we were in class, I would give you some examples. But again, I'm trying not to make this too long, and I know it's already like 20 minutes, so I'm trying to keep going fast as I can. So it says, if it does not rain, then I will walk to school. Again, I have no idea if that's true or not, but I'm looking for the pattern. Notice this is walking to school, so this is the Q. So these are going to cancel. And then it says, I will wear my walking shoes. Notice this is something new. So what they do is they put the not rain, so they put the P with the new part, and then they make their conclusion. Okay, so this is called the law of syllogism. All right, let's look at number 12. This is the law of syllogism. If you get an A on your math test, then you can go to the movies. Well, not right now with COVID, but maybe eventually. If you go to the movies, wait a minute, isn't that Q again? Okay, so long as I see that repeat and it's side by side, so it kind of like says it, repeats it, these are going to cancel out. And then notice this is a new piece. Then you can watch your favorite actor. So you really just have to rewrite this with the repetition part removed. So, and this is where math people don't love, because they don't love to write. If you get an A on your test, on your math test, then you can watch your favorite actor. And that's the law of syllogism. Okay? So let's turn the page here. And notice there's 2 more on the top. And why don't you pause it here, because actually both of those are law of syllogism if I'm glancing at them correctly. But why don't you pause it here and go ahead and give those both a try. All right. Hopefully you paused it. And again, for time's sake, I may not rewrite all these just because it takes a lot of time and I'm just trying to get through this. So if I wear my red shoes to school, then I will look sweet. If I look sweet, okay, I can tell right there. Boom. This is the law of syllogism. Then I will do well on my quiz. So you would want to say something about if, wear red shoes. Again, I'm just trying to go fast here. Then do well on quiz. You would want to write it all the way out, but I was just trying to, again, speed it up. If you do your homework, so doing homework, then you will get a good grade. And I know that's not always true. Some of you do your homework and still don't do well on quizzes and tests. I get it. We're just following the rules. So homework, good grade. Is this good grade? No, this is back to P. So this breaks our pattern. I don't even need to keep reading because my pattern is broken. So this is a no conclusion. Okay? All right, last part. They are just giving you a scenario and they're asking you to pick if it's inductive or deductive. So if we were in class, I would pick on somebody and would say which one is which. But since I'm all by myself here, inductive is patterns, deductive is laws or rules of some sort. Okay? So number 17. Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, then it will return to the ground. Okay, I remember this one. I think I remember I wanted to switch it. But basically, it's supposed to be inductive. It's supposed to be inductive because you're just watching that she's kicking a ball. But I could sort of see how somebody might say deductive because of the law of gravity. What goes up must come down. So I think I remember I wanted to switch this one because I didn't like that one. Just because it's kind of a wishy-washy one. Let's see if 18 is any better because they only give us 2 examples here. It says all multiples of 8 are divisible by 4. Well, I don't even actually have to read this because multiples and divisible, those are properties. Like like multiplication property, like division property, these are all properties. So this has to be deductive. And if you ask me to explain, I would say like the multiplication or division property of equality. So, I mean, that's where this one I don't like because are you noticing or are you saying law of gravity? So, well, that one's a wishy-washy one. But do you kind of see how I went through the thinking process there? So those 2 are the ones that they wanted you to do that. Number 19 is just completely different. So number 19, please don't feel like you have to go through. You actually will do this in GOB, but it is just an interesting pattern. So if you want to go ahead and stop the video here, feel free, stop it. If you want to try this one, go ahead and pause the video and try it. And then otherwise I'll explain it. So pause it if you want. Okay, so number 19, you're supposed to come up with how are they getting these numbers. So if you think about, a triangle, obviously the sum is 180. Okay, think about a quadrilateral. If you think about a quadrilateral is really made up of 2 triangles. So this is like 2 times 180. If you think of a pentagon, no, I'm not very good at drawing a pentagon. But if you think of a pentagon is made up of 3 triangles. So this is 3 times 180. Okay, now a hexagon. So if you think about a hexagon, let me see if I can draw 6. No. A hexagon has 6 sides. Okay, so here's a hexagon. And so if I connect, like you just pick a corner. And so this would be 1 triangle, 2, 3, 4. Do you see how there's 4 triangles here? Okay, so I have 4 times 180. So that's the pattern that they wanted you to observe. And then, so here, let me write this. This would be 1 times 180 because there's only 1 triangle. Take this number and how it relates to this front number. So if we take 4, take a look at that. And then if we take 5, take a look at the 3. Sorry, that's my dog yelping. I apologize. That's 6. And then the number. Do you notice how this is always 2 less? It's always 2 less. I'm sorry, my dog gets a little excited there. So this number out front here is always 2 less than number of sides. So if we took this front piece, we could say n is the number of sides minus 2 times 180. So let's just say you have an octagon. Okay, so you have an octagon. Has 8 sides. If you take 8 minus 2, which is 6, times 180, that would give you your total interior of an octagon. So it would be 1080. Okay, so that's a difficult pattern that they just wanted you to observe. But you will do that again in Geometry B, so don't worry too much about it. But it did show up in the student journal, so I just thought I would go over it. But that concludes lesson 2.2.